Welcome to Tech with Kaushik. This is part 6 of our complete practice question series for the AIF-C01 AWS Certified AI Practitioner exam. Choose your answer before the timer ends, then review the correct answer, explanation, and exam tip. Let us begin part 6. Next is question number 144. The topic here is AI transparency. Scenario: a machine learning team is preparing to deploy a new predictive model into a production environment. To comply with internal governance standards, they use Amazon SageMaker model cards. What is the primary benefit of using this feature? Review the options. Choice A. It provides a standardized way to document model purpose, evaluation results, and known limitations. Choice B. It automatically optimizes the computational resources required for model inference. Choice C. It encrypts model artifacts in transit and at rest using AWS KMS. Choice D. It generates synthetic training data to balance underrepresented minority groups. The required response is A. It provides a standardized way to document model purpose, evaluation results, and known limitations. This option satisfies the complete requirement because Amazon SageMaker model cards serve as a single source of truth for model information, helping organizations standardize documentation regarding a model's intended use, risk ratings, training details, and evaluation metrics. This promotes transparency and responsible AI governance. Check why each remaining option is not the best fit. B. Model cards are for documentation and governance. They do not optimize computational resources. C. Encryption is handled by AWS KMS, not by SageMaker model cards. D. Generating synthetic data is a data preparation technique, unrelated to the documentation purpose of model cards. Use this elimination rule in the exam. SageMaker model cards are used for model documentation, governance, and improving AI transparency. Approach question number 145. By checking every constraint. Pay attention to qualifiers such as least, most, and minimum. A data scientist is evaluating the performance of a newly trained binary classification model. The evaluation report highlights the model's F1 score as the primary metric of success. What does the F1 score represent in this context? Eliminate every option that violates even one requirement. Consider option A. The computational time required to generate a single prediction. Consider option B. The harmonic mean of the model's precision and recall. Consider option C. The financial cost of operating the model per 1,000 tokens. Consider option D. The percentage of training data that the model successfully memorized. The correct choice is B. The harmonic mean of the model's precision and recall. Here is the reasoning that confirms the answer. In machine learning, the F1 score is a metric used to evaluate the performance of a classification model. It is calculated as the harmonic mean of precision and recall, providing a single metric that balances both false positives and false negatives. The incorrect choices are plausible but unsuitable because A. Model speed is measured by latency or throughput, not the F1 score. C. Financial cost is measured by standard billing metrics, unrelated to the F1 score. D. Memorizing training data is a sign of overfitting, not what the F1 score measures. The F1 score is the harmonic mean of precision and recall, making it an excellent metric when you have uneven class distribution. Focus on the key wording in question number 146. The key exam clue is contained in this scenario. A company wants to deploy an AI chatbot to answer employee questions about internal IT policies. These policies change frequently. The company requires accurate, current answers without repeatedly changing the foundation model's weights. Which architecture best satisfies these requirements? The exam distinction is hidden in these choices. Option A. Fine-tune the foundation model whenever the policy documents change. Option B. Use continued pre-training on the foundation model whenever the policy documents change. Option C. Use retrieval augmented generation, RAG, with an external knowledge base. Option D. Increase the model temperature to generate more diverse policy answers. The option that satisfies the complete requirement is C. Use retrieval augmented generation, RAG, with an external knowledge base. The requirement to solution matches RAG retrieves current policy content from an external knowledge source at inference time and supplies it as context to the foundation model. The company can update the knowledge source without repeatedly fine-tuning or continuing pre-training. Now eliminate the distractors. A. Repeated fine-tuning changes model weights and adds unnecessary cost and maintenance for frequently changing documents. B. Continued pre-training uses large amounts of unlabeled text to adapt model weights and is not efficient for routine policy updates. D. Higher temperature increases variation and does not provide current policy knowledge. A useful exam pattern is this. Use RAG for frequently changing external knowledge. Use model customization when the required behavior or domain adaptation must be learned in the weights. Let's break down question number 147. The focus now shifts to bias and fairness. Review the scenario and identify what must be achieved. An HR department adopted an AI-based tool to screen job applications. It was later discovered that the tool disproportionately rejected candidates from certain geographic regions because the historical training data lacked representation from those areas. Which responsible AI principle is directly compromised in this scenario? Now compare the choices one requirement at a time. Choice A. Explainability. Choice B. Fairness. Choice C. Transparency. Choice D. Privacy. The best answer is B. Fairness. The decisive reason is fairness in responsible AI involves ensuring that models do not exhibit bias or discriminate against specific groups or demographics. An unrepresentative training dataset leading to disproportionate rejections is a direct violation of the fairness principle. Here is how to rule out the alternatives. A. Explainability is the ability to understand how a model arrives at its decisions, not whether the decision is biased. C. Transparency involves clear communication about the use and limitations of AI. D. Privacy involves protecting sensitive personal data. Remember this decision rule. When a model's outcomes disadvantage a specific demographic due to skewed training data, it is a fairness issue. Let's analyze question number 148. Read the scenario with the target outcome in mind. A heavily regulated healthcare organization is building machine learning applications on AWS. The compliance team requires continuous monitoring of AWS resource configurations and the ability to automatically map these configurations to industry regulatory frameworks to ensure audit readiness. Which combination of AWS services should the organization use to meet these requirements? Choose 2. Select all answers that satisfy the complete requirement. Check each option against the exact requirement. Option A is AWS Audit Manager. Option B is AWS Config. Option C is Amazon CloudFront. Option D is AWS Direct Connect. Option E is Amazon S3 Glacier. After elimination, select A. AWS Audit Manager. B. AWS Config. The key clue points here because AWS Audit Manager helps continuously audit AWS usage and map configurations to compliance frameworks. AWS Config continuously monitors and records AWS resource configurations, enabling compliance assessments against internal policies. Together, they satisfy the requirement for monitoring and regulatory mapping. C. Amazon CloudFront is a content delivery network, CDN, unrelated to compliance monitoring. D. AWS Direct Connect provides dedicated network connections, not compliance auditing. E. Amazon S3 Glacier is for long-term data archiving, not for actively assessing resource configurations. Watch for this clue in similar questions. For compliance mapping and continuous resource configuration monitoring, combine AWS Audit Manager and AWS Config. Question number 149 contains an important exam distinction. This question moves us into model customization. This scenario tests whether you recognize the controlling constraint. A developer is unsatisfied with the tone of the responses generated by an Amazon Bedrock Foundation model. The developer needs a fast and highly cost-effective way to improve the output without altering model weights or building complex infrastructure. Which approach should the developer take first? Focus on which option satisfies the complete requirement. Now examine choice A. Perform full parameter fine-tuning on the foundation model. Now examine choice B. Pre-train a custom model from scratch using proprietary data. Now examine choice C. Apply prompt engineering techniques to refine the instructions. Now examine choice D. Provision dedicated throughput for the model endpoint. The correct choice is C. Apply prompt engineering techniques to refine the instructions. Prompt engineering is the process of modifying the input provided to a model to guide its output. It requires no infrastructure, no training compute, and does not alter model weights, making it the fastest and most cost-effective way to improve model responses. The remaining options fail one or more requirements because A. Full parameter fine-tuning is computationally expensive and alters model weights. B. Pre-training a model from scratch is the most expensive and time-consuming option. D. Provision throughput guarantees capacity but does not improve the quality or tone of the model's responses. Exam strategy. Always attempt prompt engineering first to improve model outputs before moving to more expensive customization methods like fine-tuning. Now tackle question number 150. A gaming community forum wants to automatically flag toxic or abusive English language comments. The moderation team has no label training dataset and lacks machine learning expertise. Which AWS capability can identify harmful language without custom model training? Compare the options. Option A. Amazon Comprehend Toxicity Detection. Option B. Amazon Recognition Content Moderation. Option C. Amazon Transcribe Vocabulary Filtering. Option D. Amazon SageMaker Autopilot. The required response is A. Amazon Comprehend Toxicity Detection. This option satisfies the complete requirement because Amazon Comprehend provides a managed detect toxic content capability for analyzing English text and returning toxicity labels and scores. The application can use those results to flag or remove comments without training a custom model. Check why each remaining option is not the best fit. B. Amazon Recognition Content Moderation analyzes images and video, not text comments. C. Amazon Transcribe Vocabulary Filtering modifies speech-to-text output and does not classify written comments for toxicity. D. Amazon SageMaker Autopilot builds custom models and would require suitable training data. Use this elimination rule in the exam. Use Amazon Comprehend toxicity detection for harmful English text. Use Amazon Recognition content moderation for inappropriate images or video. Question number 151. Find the decisive clue before choosing. Look for the wording that eliminates the distractors. A retail company deployed a custom machine learning model to an Amazon SageMaker AI real-time endpoint to predict inventory demand. Actual demand outcomes become available after each sales period. The data science team needs to monitor ongoing model accuracy and receive alerts when live input data drifts from the training baseline. Which AWS service or feature provides these monitoring capabilities? Watch for distractors that are valid services but wrong for this scenario. Next, option A, Amazon SageMaker Model Monitor. Next, option B, Amazon Comprehend. Next, option C, Amazon SageMaker Clarify. Next, option D, Amazon Recognition. After elimination, select A, Amazon SageMaker Model Monitor. Here is the reasoning that confirms the answer. Amazon SageMaker Model Monitor can monitor data quality drift for SageMaker AI inference workloads and model quality metrics such as accuracy. Model quality monitoring compares captured predictions with actual ground truth labels and can publish alerts through Amazon CloudWatch. The incorrect choices are plausible but unsuitable because B, Amazon Comprehend analyzes text and does not monitor deployed custom model quality. C, Amazon SageMaker Clarify focuses on bias detection and explainability. Model Monitor is the production monitoring capability. D, Amazon Recognition analyzes images and video and does not monitor a custom SageMaker AI endpoint. Data quality monitoring detects input drift. Monitoring accuracy or other model quality metrics also requires actual ground truth outcomes. For question number 152. Separate the requirement from the distractors. Identify the decisive constraint before considering the options. An enterprise is scaling its use of machine learning models. The AI governance team mandates that every deployed model must have standardized documentation detailing its intended use cases, risk ratings, and underlying training data to provide transparency to internal stakeholders. Which AWS service or feature should the company use to create and store this documentation? Compare the options by fit, not by familiarity. Consider option A, Amazon Comprehend. Consider option B, Amazon SageMaker Model Cards. Consider option C, Amazon LEX. Consider option D, Amazon Recognition. The option that satisfies the complete requirement is B, Amazon SageMaker Model Cards. The requirement to solution match is Amazon SageMaker Model Cards provide a single, centralized location to document critical details about machine learning models. This includes intended use cases, risk ratings, training parameters, and evaluation results. They are a core governance tool designed to provide transparency to stakeholders regarding how a model was built and how it should be used. Now eliminate the distractors. A. Amazon Comprehend is an NLP service, not a governance documentation tool. C. Amazon LEX is used for building conversational chatbots, not documenting model metadata. D. Amazon Recognition is for image and video analysis. A useful exam pattern is this. For ML governance, standardization, and providing transparency through documentation, recording intended uses and limitations, always select Amazon SageMaker Model Cards. Question number 153. Tests careful elimination. Identify the decisive constraint before considering the options. A global e-commerce platform stores millions of product descriptions in English. The platform's expansion team wants to automatically convert these descriptions into Spanish, French, and German to serve local markets. Which AWS service is purpose-built to automate this text conversion? Watch for distractors that are valid services but wrong for this scenario. Next, option A, Amazon Transcribe. Next, option B, Amazon Kandra. Next, option C, Amazon Translate. Next, option D, Amazon Polly. The best answer is C, Amazon Translate. The decisive reason is Amazon Translate is a highly accurate, fully managed neural machine translation service that delivers fast, high-quality, and affordable language translation. It is the exact service required to convert text, like product descriptions, from one language to multiple other languages. Here is how to rule out the alternatives. A. Amazon Transcribe converts spoken audio into text, speech to text. B. Amazon Kandra is an intelligent enterprise search service powered by machine learning. D. Amazon Polly converts written text into lifelike spoken audio, text to speech. Remember this decision rule. Match the AI service to the modality. Translate is equal to text, different languages. Transcribe is equal to audio to text. Polly is equal to text to audio. Question number 154. Tests careful elimination. Look for the wording that eliminates the distractors. An AI development team is selecting appropriate model customization and data preparation methods for several projects. Select the appropriate methodology for each use case. Complete every statement by matching the requirement to the option. The first blank appears in, the team needs to adapt a foundation model to specialized domain vocabulary by training it further on a massive corpus of unstructured text. This requires the blank. The candidates are 1. Continued pre-training, data augmentation, or model fine-tuning. The second blank appears in, the team has limited labeled image data and needs to artificially expand the dataset to reduce overfitting. This requires the blank. The candidates are 2. Continued pre-training, data augmentation, or model fine-tuning. The third blank appears in, the team needs to adapt a model to a specific instruction following task by using curated prompt and response examples. This requires the blank. The candidates are 3. Continued pre-training, data augmentation, or model fine-tuning. Question type, drop-down. The correct answer is 1. Continued pre-training. 2. Data augmentation. 3. Model fine-tuning. Here is why this answer is correct. Continued pre-training adapts a foundation model by training it further on large amounts of unlabeled domain text. Data augmentation creates additional training examples from limited labeled data. Fine-tuning uses task-specific examples, such as prompt and response pairs, to adapt model behavior. Answer rows. 1. The team needs to adapt a foundation model to specialized domain vocabulary by training it further on a massive corpus of unstructured text. This requires select. Vertical bar continued pre-training. Vertical bar continued pre-training adapts the model to domain language using unstructured text. 2. The team has limited labeled image data and needs to artificially expand the dataset to reduce overfitting. This requires select. Vertical bar data augmentation. Vertical bar data augmentation creates varied training examples from the available labeled images. 3. The team needs to adapt a model to a specific instruction following task by using curated prompt and response examples. This requires select. Vertical bar model fine-tuning. Vertical bar fine-tuning updates model behavior using task-specific input-output examples. Here is an important exam tip. Unlabeled domain text suggests continued pre-training. Labeled task examples suggest fine-tuning. Synthetic variations suggest data augmentation. Work through question number 155. Step by step. We are moving to tokens and context. Start by separating the facts from the requirement. A legal tech startup is using a foundation model to generate brief summaries of court transcripts. The application works perfectly for short hearings but consistently fails and returns an error when users attempt to summarize multi-day, 200-page trial transcripts. What is the most likely cause of this failure? Use the scenario constraints to assess these choices. Choice A. The input tokens exceed the model's context window size. Choice B. The temperature parameter is set too high for long documents. Choice C. The top p-value is restricting the model's vocabulary limit. Choice D. The selected foundation model does not support instruction fine-tuning. The best answer is A. The input tokens exceed the model's context window size. The key clue points here because every foundation model has a strict technical limit on how much data it can process in a single request, known as the context window. If a user pastes a massive document, like a 200-page transcript, into the prompt and it exceeds the maximum token limit, the model will fail to process the request and return an error. B. Temperature controls output randomness. While high temperature might yield a strange summary, it will not cause a systematic failure based purely on document length. C. Top P limits the vocabulary choices during generation. It does not cause failures based on input length. D. Whether a model supports fine-tuning has no relation to its ability to perform inference on a large prompt. Watch for this clue in similar questions. If an application fails exclusively when processing very long documents, chat histories, or prompts, the cause is exceeding the model's context window limit. Question number 156. Find the decisive clue before choosing. Pay attention to qualifiers such as least, most, and minimum. A news organization is deploying a retrieval-augmented generation (RAG) system so subscribers can chat with a bot about past articles. Thousands of new articles are published daily. To ensure the chat system responds to users in near real time, the data engineering team wants to decouple the data ingestion process from the user's live chat request. Which two steps of the RAG workflow should be implemented as offline, asynchronous batch processes? Choose 2. Check all options because multiple selections may be required. Eliminate every option that violates even one requirement. Consider option A, generation of embeddings for the user's specific chat queries. Consider option B, retrieval of relevant content chunks from the vector database. Consider option C, generation of content embeddings for the newly published articles. Consider option D, response generation by the foundation model. Consider option E, creation and updating of the vector search index. The correct choice is C, generation of content embeddings for the newly published articles. E, creation and updating of the vector search index. In ARAG architecture, data preparation must happen before a user can query it. Generating embeddings for the massive volume of new daily articles and updating the vector search index are computationally heavy tasks that should be processed asynchronously, offline, as background batch jobs. This ensures the data is ready for instant retrieval when a user initiates a live chat. The remaining options fail one or more requirements because A. Generating embeddings for the user's live query must happen in real-time online, otherwise the system cannot understand the question. B. Retrieving content chunks must happen online in real-time in response to the user's specific query. D. Response generation by the LLM must happen online in real time so the user receives their answer immediately. Exam strategy. In RAG, data ingestion, chunking, embedding, indexing is an offline background process. Inference, query embedding, searching, generating is an online real-time process. Question number 157. Next, we enter the topic of AI use case selection. Identify the requirement in this scenario. A retail bank is evaluating several proposed artificial intelligence projects. The Chief Technology Officer wants to prioritize projects that leverage generative AI rather than traditional predictive machine learning. Which proposed project represents a generative AI use case? The choices are: Choice A, classifying customers into risk tiers based on historical product usage. Choice B, generating readable summaries from long-form customer complaint emails. Choice C, segmenting wealth management customers based on their investment portfolios. Choice D, forecasting quarterly revenue for specific loan products. The required response is B, generating readable summaries from long-form customer complaint emails. This option satisfies the complete requirement because generative AI involves creating net new, unstructured content such as text, images, or code. Summarizing long-form emails requires natural language understanding and the generation of new text sentences, making it a classic generative AI use case. Check why each remaining option is not the best fit. A. Classifying customers into risk tiers is a predictive classification task, traditional ML. C. Segmenting customers based on portfolios is a clustering task, traditional unsupervised ML. D. Forecasting quarterly revenue is a time series regression task, traditional ML. Use this elimination rule in the exam. If the AI output is a category, classification, a number, regression, or a grouping, clustering, it is traditional ML. If the output is new text, images, or audio, it is generative AI. Question number 158. Scenario. A financial institution requires strict governance over its machine learning lifecycle. Data scientists must record detailed metadata about every model, including its training datasets, evaluation results, and intended business uses, in a centralized repository before deployment. Which AWS feature provides this standardized model reporting capability? Options. Option A, Amazon SageMaker Jumpstart. Option B, Amazon SageMaker Debugger. Option C, Amazon SageMaker Model Monitor. Option D, Amazon SageMaker Model Cards. After elimination, select D, Amazon SageMaker Model Cards. Here is the reasoning that confirms the answer. Amazon SageMaker Model Cards provide a centralized, standardized repository to document machine learning models for governance and compliance. Data scientists use them to record essential metadata, such as the intended use cases, risk assumptions, training datasets, and performance evaluation metrics of a model. The incorrect choices are plausible, but unsuitable because A. SageMaker Jumpstart is a hub for pre-trained models and solutions, not a governance reporting tool. B. SageMaker Debugger is used to monitor and profile training jobs in real time to detect bottlenecks or vanishing gradients, not to record overall governance metadata. C. SageMaker Model Monitor observes models in production for data drift. It does not serve as the static documentation record for governance. For documenting model details, governance, transparency, and intended uses, the correct feature is always Amazon SageMaker Model Cards. Approach question number 159. By checking every constraint. Identify the decisive constraint before considering the options. A healthcare provider wants to build an automated pipeline that can read unstructured, typed English language clinical notes, identify medical conditions and medications, and output a structured, readable summary. Which architectural approach fulfills these requirements? Compare the options by fit, not by familiarity. Next, option A. Use Amazon Comprehend Medical to extract medical entities, then apply rule-based formatting logic to generate the structured summary. Next, option B. Use Amazon Personalize to track patient interactions, then integrate the output into a generalized text translation tool. Next, option C. Use Amazon Textract to extract text from images, then apply keyword searching algorithms to locate summaries. Next, option D. Use Amazon Kandra to index the patient records, then use a template-based system to match the exact keywords. The option that satisfies the complete requirement is A. Use Amazon Comprehend Medical to extract medical entities, then apply rule-based formatting logic to generate the structured summary. The requirement to solution match is Amazon Comprehend Medical uses pre-trained NLP models to detect medical entities such as conditions and medications in unstructured English clinical text. Rule-based formatting can then organize the extracted entities into the required structured summary. Now eliminate the distractors. B. Amazon Personalize builds recommendations and does not extract clinical entities. C. Amazon Textract performs OCR on scan documents, the notes are already typed, and keyword matching does not provide medical entity recognition. D. Amazon Kandra supports enterprise search but is not a medical entity extraction service. A useful exam pattern is this. Use Amazon Comprehend Medical for entity extraction from English clinical text. Use Amazon Textract when text first must be extracted from document images. For question number 160. Separate the requirement from the distractors. Pay attention to qualifiers such as least, most, and minimum. A hotel chain wants to build a conversational assistant. The assistant must use a large language model, LLM, to interact with users naturally and must pull factual information from the company's internal knowledge base of booking policies. The company wants to deploy this solution with the absolute minimum amount of custom coding. Which approach meets these requirements with the least development effort? Watch for distractors that are valid services but wrong for this scenario. Next, option A. Train a custom foundation model from scratch using Amazon SageMaker Autopilot. Next, option B. Develop a retrieval augmented generation, RAG, agent using Amazon Bedrock. Next, option C. Write a custom Python application orchestrated entirely by Amazon Q Developer. Next, option D. Fine-tune an open-source model using Amazon SageMaker Jumpstart. The option that satisfies the complete requirement is B. Develop a retrieval augmented generation, RAG, agent using Amazon Bedrock. The decisive reason is Amazon Bedrock provides managed, serverless tools to easily build RAG applications and conversational agents. By using knowledge bases and agents for Amazon Bedrock, developers can connect a top-tier LLM directly to corporate data with minimal configuration, representing the absolute least development effort. Here is how to rule out the alternatives. A. Training a custom model from scratch is incredibly complex, expensive, and requires massive ML expertise and data engineering effort. C. Writing a custom Python application orchestrated manually requires significant coding, debugging, and infrastructure management compared to managed Bedrock features. D. Fine-tuning an open-source model requires data preparation, training compute, and custom deployment, which requires far more effort than simply configuring a managed RAG agent. Remember this decision rule. To connect an LLM to internal data with the least development effort, use managed retrieval augmented generation, RAG, via knowledge bases for Amazon Bedrock. Next, question number 161. A machine learning engineer is preparing a massive dataset of English literature to train a new natural language processing (NLP) model. The first step in the data pipeline involves tokenization. What is the purpose of the tokenization process in this workflow? Option A. To translate the English text into numerical vector embeddings. Option B. To compress the physical size of the text files for cheaper storage. Option C. To securely encrypt sensitive words within the text data. Option D. To break the raw text into smaller linguistic units for the model to process. The best answer is D. To break the raw text into smaller linguistic units for the model to process. The key clue points here because in natural language processing, NLP, and generative AI, machine learning models cannot read raw string text directly. Tokenization is the critical first step that breaks raw text down into smaller, manageable chunks, tokens, which can be words, subwords, or characters, so they can later be converted into numerical vectors. A. Translating text into numerical vectors is the job of an embedding model, which happens after tokenization. B. Tokenization is a data preparation step for ML algorithms. It is not a file compression technique for saving storage space. C. Tokenization has nothing to do with cryptography or securing sensitive information. Watch for this clue in similar questions. Tokenization is the act of splitting text into smaller pieces, tokens. Embedding is the act of turning those tokens into math, vectors. Start by identifying the requirement in question number 162. First, locate the key operational constraint. A data scientist is explaining the underlying architecture of modern large language models, LLMs, to a group of stakeholders, focusing on why these models are so effective at understanding long-range dependencies in text. Which defining characteristic of transformer-based models gives them this capability? Review the options and eliminate any clear mismatch. Option A is they process data sequences one element at a time in slow, cyclic iterations. Option B is they use self-attention mechanisms to weigh the contextual importance of all words in a sequence simultaneously. Option C is they rely exclusively on convolutional layers to apply localized filters across the input data. Option D is they are rigidly designed to process only text data and cannot handle other modalities. The correct choice is B. They use self-attention mechanisms to weigh the contextual importance of all words in a sequence simultaneously. The core innovation of the transformer architecture is the self-attention mechanism. Unlike older sequential models, self-attention allows the model to look at every word in a sequence simultaneously and calculate how important each word is to every other word, giving it a profound understanding of deep context and long-range dependencies. The remaining options fail one or more requirements because A. Older recurrent neural networks, RNNs, process data sequentially one element at a time. Transformers process data in parallel, which makes them faster and better at long contexts. C. Convolutional neural networks, CNNs, rely on localized filters and are primarily used for image processing, not modern LLM text architectures. D. Transformer models are highly versatile and are the foundation for multimodal models that can process text, images, and audio natively. Exam strategy. Transformers is equal to self-attention mechanism plus parallel processing. This is what makes modern LLMs so powerful compared to older sequential algorithms. Move to question number 163. This question moves us into AI compliance. Review the scenario. A multinational insurance provider uses a predictive machine learning model to automatically approve or deny customer policy applications. The company is expanding this automated system into a new geographic region with strict regulatory frameworks regarding automated decision-making. Which type of compliance law is most directly relevant to deploying this specific AI system? Option A. Local health data protection laws. Option B. Local algorithm accountability laws. Option C. Local education privacy laws. Option D. Local payment card data protection laws. The required response is B. Local algorithm accountability laws. This option satisfies the complete requirement because algorithm accountability and AI decision-making laws can govern automated systems that materially affect people, including automated insurance underwriting or eligibility decisions. Such rules can impose requirements for fairness, transparency, documentation, and human review. Check why each remaining option is not the best fit. A. Health data protection laws apply when protected medical information is processed. That is not the stated issue. C. Education privacy laws protect student records and do not govern insurance application decisions. D. Payment card standards govern cardholder data security, not the accountability of automated insurance decisions. Use this elimination rule in the exam. For AI systems making consequential decisions in areas such as insurance, lending, hiring, or housing, check applicable algorithm accountability and AI governance rules. Work through question number 164. Step by step. Review the scenario and identify what must be achieved. A social media platform is integrating a generative AI content generator via Amazon Bedrock. The trust and safety team wants to use guardrails for Amazon Bedrock to automatically block the model from generating unsafe or toxic responses. Which two content categories are natively supported by the standard content filters and guardrails for Amazon Bedrock? Choose two. Choose every applicable answer and reject partial matches. Use the scenario constraints to assess these choices. Choice A. Religion. Choice B. Hate. Choice C. Gambling. Choice D. Violence. Choice E. Politics. After elimination, select B. Hate. D. Violence. Here is the reasoning that confirms the answer. Guardrails for Amazon Bedrock content filters support predefined harmful content categories that include hate and violence. Other supported categories include insults, sexual, misconduct, and prompt attack, with prompt attack availability depending on the guardrail tier. The incorrect choices are plausible, but unsuitable because A. Religion is not a predefined harmful content category, though a custom denied topic can restrict it. C. Gambling is not a predefined content filter category and can be handled through denied topics when required. E. Politics is not a predefined harmful content category and can be configured as a denied topic. Content filters cover predefined harmful categories. Use denied topics to block a broader business-specific subject such as politics or gambling. Let's analyze question number 165. Next, we enter the topic of prompt engineering. Start by separating the facts from the requirement. An organization is heavily investing in prompt engineering to align a large language model's outputs with its brand guidelines. While prompt engineering is effective at shaping behavior, the security team is documenting the inherent limitations and risks of relying solely on this technique. Which statement accurately describes a key limitation of prompt engineering? Now compare the choices one requirement at a time. Option A is prompt engineering does not ensure that the model will always produce consistent, reliable, and deterministic outputs. Option B is applying advanced prompt engineering techniques permanently eliminates the risk of data poisoning during the model's training phase. Option C is prompt engineering provides a foolproof mathematical guarantee that the model will never hallucinate false facts. Option D is using prompt engineering automatically encrypts the input data, hiding it from the underlying foundation model. The option that satisfies the complete requirement is A. Prompt engineering does not ensure that the model will always produce consistent, reliable, and deterministic outputs. The requirement to solution matches because large language models are probabilistic by nature. A major limitation of prompt engineering is that it cannot provide a 100% guarantee of determinism. Even with a perfectly crafted prompt, the model might occasionally generate a slightly different phrasing, hallucinate, or deviate from the instructions. Now eliminate the distractors. B. Data poisoning happens during the pre-training phase when malicious data is injected into the training dataset. Prompt engineering occurs at inference time and has no impact on historical data poisoning. C. Prompt engineering significantly reduces hallucinations by grounding the model with context, but it does not provide a foolproof mathematical guarantee. D. Prompt engineering involves sending plain text instructions to the model. It does not encrypt data or hide it from the underlying architecture. A useful exam pattern is this. Prompt engineering guides behavior but cannot overcome the fundamental probabilistic, random nature of LLMs. It does not guarantee determinism or mathematically prevent hallucinations. Let's break down question number 166. Read the scenario with the target outcome in mind. A developer is building an AI tool to write complex software documentation. Asking the LLM to write the entire document in one prompt results in poor quality. Instead, the developer writes a script that first asks the model to generate an outline, then uses that outline in a second prompt to ask for the introduction, and so on. Which technique is the developer implementing? Review the options and eliminate any clear mismatch. Choice A. Prompt chaining. Choice B. One-shot prompting. Choice C. Retrieval augmented generation, RAG. Choice D. Tree of thoughts. The required response is A. Prompt chaining. The decisive reason is prompt chaining is a technique where a complex task is broken down into a sequence of smaller, manageable prompts. The output from the first prompt, like generating an outline, is passed as the input to the next prompt, like writing the introduction, resulting in higher quality outputs for complex workflows. Here is how to rule out the alternatives. B. One-shot prompting provides exactly one example of the desired output within a single prompt. It does not involve a sequential chain of multiple prompts. C. RAG retrieves external data from a database to append to a prompt. It is not the act of linking sequential prompts together. D. Tree of thoughts is an advanced reasoning technique where the model explores multiple different reasoning paths simultaneously and evaluates them. It is not simply chaining sequential subtasks. Remember this decision rule. Breaking a large task into sequential steps where the output of prompt 1 becomes the input of prompt 2 is called prompt chaining. Start by identifying the requirement in question number 167. The focus now shifts to embeddings. First, locate the key operational constraint. A company is building a semantic search engine. The engine converts millions of text documents into a representation that allows mathematical comparison of words, sentences, and concepts. Which description best defines the representation used for this purpose? Check each option against the exact requirement. Option A is a visualization technique for high-dimensional business intelligence data. Option B is a numerical method for representing semantic data as vectors in a continuous space. Option C is an encryption hashing method for securing sensitive training data. Option D is a compression algorithm designed to reduce the storage footprint of large datasets. The best answer is B. A numerical method for representing semantic data as vectors in a continuous space. The key clue points here because in machine learning, Embeddings are numerical representations, vectors, of real-world objects, like words, sentences, or images. By converting text into high-dimensional vectors, models can mathematically compare the semantic similarity of different concepts. For example, understanding that dog is closer to puppy than to car. A. Embeddings are not visualization tools for business intelligence dashboards. C. Embeddings do not encrypt data, they are mathematical translations of data, but anyone with the embedding model can understand the semantic proximity. D. While embeddings are a denser representation than one-hot encoding, they are not a file compression algorithm designed to save hard drive space. Watch for this clue in similar questions. If a question asks how AI understands meaning, measures similarity, or performs semantic search, the answer is always embeddings or vectors. Move to question number 168. Review the scenario. A media startup built an automated newsletter generator using a foundation model on Amazon Bedrock. Users have complained that the AI occasionally includes controversial political commentary. The developers want to completely block the AI from discussing politics without trying to rewrite the base model's prompt instructions. Which feature of guardrails for Amazon Bedrock is specifically designed to enforce this restriction? Review the options. Choice A. Content filters. Choice B. Sensitive information filters. Choice C. Denied topics. Choice D. Word filters. The correct choice is C. Denied topics. Guardrails for Amazon Bedrock includes a denied topics feature. This allows administrators to define custom, natural language topics, such as politics, cryptocurrency, or competitor names, that the application should strictly avoid. If the LLM attempts to generate content related to a denied topic, the guardrail blocks it. The remaining options fail one or more requirements because A. Content filters, the native ones, block universally unsafe content like hate speech, violence, and sexual content. They do not block general subjects like politics. B. Sensitive information filters, PII filters, redact data like social security numbers or credit cards, not political commentary. D. Word filters block exact, specific strings, like profanity or a specific brand name, but are highly ineffective at blocking a broad, conceptual topic like politics. Exam strategy. To block a broad subject matter, like investment advice, politics, or medical diagnoses, without writing complex prompt rules, use the Denied Topics feature in guardrails for Amazon Bedrock. Question number 169. Find the decisive clue before choosing. Look for the wording that eliminates the distractors. An enterprise has dozens of predictive models deployed to Amazon SageMaker AI endpoints. The MLOps team captures inference data, and actual outcomes become available later. The team needs a managed capability to detect data drift and alert when model accuracy degrades from its baseline. Which AWS service or feature provides this capability? Compare the options by fit, not by familiarity. Consider option A, Amazon SageMaker Data Wrangler. Consider option B, Amazon SageMaker Jumpstart. Consider option C, Amazon SageMaker Hyperpod. Consider option D, Amazon SageMaker Model Monitor. After elimination, select D, Amazon SageMaker Model Monitor. This option satisfies the complete requirement because Amazon SageMaker Model Monitor supports scheduled monitoring of SageMaker AI inference workloads. It can detect input data drift and, when ground truth outcomes are supplied, compare predictions with actual labels to monitor model quality metrics such as accuracy and publish alerts. Check why each remaining option is not the best fit. A. SageMaker Data Wrangler prepares and transforms data, It does not monitor production endpoints. B. SageMaker Jumpstart provides pre-trained models and solution templates. C. SageMaker Hyperpod provides resilient infrastructure for large-scale model training, not production drift monitoring. Use this elimination rule in the exam. Model Monitor can detect data drift from captured inference data. Model quality monitoring additionally requires ground truth labels. Work through question number 170. Step by step. We are moving to our AG architecture. First, locate the key operational constraint. When constructing a retrieval-augmented generation, RAG, system, a data engineer must decide how to process large, 100-page PDF reports before storing them in a vector database. The engineer implements a strategy to split the documents into smaller paragraphs. What is the primary technical reason for chunking documents in a RAG architecture? Review the options and eliminate any clear mismatch. Choice A. To decrease the financial cost of cloud storage by compressing the size of the text. Choice B. To improve the contextual relevancy of search results and ensure retrieved texts fit within the LLMS context window. Choice C. To bypass the need to convert the text data into mathematical vector embeddings. Choice D. To overcome hard storage limitations that prevent modern databases from holding large text files. The option that satisfies the complete requirement is B. To improve the contextual relevancy of search results and ensure retrieved texts fit within the LLMS context window. Here is the reasoning that confirms the answer. Chunking lets a RAG system retrieve focused passages instead of entire documents. The application can then include only the most relevant chunks within the model's available context budget, improving retrieval precision and reducing irrelevant context even when the full document might technically fit. The incorrect choices are plausible, but unsuitable because A. Chunking does not compress the source text and can increase storage after metadata and embeddings are added. C. Chunks normally still need embeddings or another searchable representation for semantic retrieval. D. Vector stores can hold references to large documents. Chunking is primarily for retrieval quality and context management. Chunking improves retrieval granularity and helps keep the selected evidence within the model's context budget. For question number 171. Separate the requirement from the distractors. Identify the decisive constraint before considering the options. A pharmaceutical company is collaborating with external university researchers to build predictive models. The consortium requires a central, standardized system on AWS to record the life cycle of each model, including its intended purpose, risk assumptions, training parameters, and version history. Which solution provides this standardized model tracking capability? Eliminate every option that violates even one requirement. Consider option A. Track the model changes by using Amazon Comprehend. Consider option B. Track the model changes by using Amazon SageMaker model cards. Consider option C. Track the model changes by using standard Git commit logs. Consider option D. Track the model changes by using Amazon Fraud Detector. After elimination, select B. Track the model changes by using Amazon SageMaker model cards. The requirement to solution match is Amazon SageMaker model cards provide a centralized, standardized repository to record comprehensive details about a machine learning model. This includes version tracking, intended use cases, evaluation metrics, and development history, making it the perfect governance tool for collaboration across different institutions. Now eliminate the distractors. A. Amazon Comprehend is a natural language processing service used to analyze text sentiment, not a governance tracking tool. C. Git commit logs track code changes at a technical level, but they do not provide standardized, business-level governance documentation for AI model risk, data, and life cycle tracking. D. Amazon Fraud Detector is an AI service used to identify fraudulent online activities entirely unrelated to model documentation. A useful exam pattern is this. For standardizing documentation, sharing model details for collaboration, and ensuring governance compliance, always use Amazon SageMaker model cards. You have completed part 6 of the AIF-C01 exam practice series. Continue your preparation by opening the complete playlist and watching the remaining parts in sequence. Please like this video, subscribe to Tech with Kaushik, and enable notifications for more certification exam preparation content. Share your score, questions, or feedback in the comments. Thank you for watching. See you in the next part.